So remember, if we need the strength of electric field between the parallel plates, so what is the formula to get the strength of electric field? It is voltage divided by charge. Sorry, voltage divided by distance, not the charge, V over D. So V is the voltage or the potential. So how much is the potential difference? This is 0 and this is plus 10. So the potential difference is 10 volts. And how much is the distance between the plates? It's 20 centimeter. It should be in meter. So we divide it by 100. So it will become 0.2. So 100 divided by 10 divided by 0.2, what we'll get? We'll get 50 volts per meter. So 50 volts per meter, that is strength, because and 50 volt per meter means, because we know the parallel plates, whenever we have the parallel plate, the strength of the electric field is constant. It does not change from place to place, so it will remain unchanged, or it remain constant anywhere. And what about the direction of electric field? Direction of electric field, we know if we have parallel plate, this is a positive plate, the zero potential is a negative plate. So direction of electric field is out from positive and into negative. So the electric field lines will point downward at all the point, the resultant. So what is the strength, which electric field strength is there, as well as the direction? So what is the strength? The strength will be 50. And what about the direction? The direction will be downward. So B will be the right answer. Is it clear, this one? No, it's not always down. It depends on the which plate is positive or negative. If they change the question, and let's say if they change the question and they said now the electrodes are different, the downward is a higher potential, it is plus 10 volts, and this is a negative or 0 volts. So 0 volt means negative, like lower potential means negative, and higher potential means positive. So now the direction of electric, because we know the direction of electric field is always out from positive and into negative. So in this case, it will be upward in that case. And even the potential difference they can provide, like it's not like always they give 0. Let's say this was 10, this was written 10, and this was written 200. Now, which one will have a higher voltage? So the one which has a higher magnitude is a higher voltage. So means this will be counted as positive and this will be counted as negative. And when we substitute, like finding the strength, it's a potential difference divided by the distance between the plates. So the potential difference, if one is 10, another one is 200. So the potential difference will be 190. So we substitute the potential difference and divide it by distance. Here, one of the plate is already negative, so the potential difference will be same as the potential of one of the plate. Next question. Use the chat to answer. In this question, we have a point charge plus Q is there. You can see this is a plus Q, and a point charge negative Q are placed at X and Y respectively. When another charge is placed at Z, so there is another charge placed at Z, the resultant force on the charge is 0. Means when we place any charge here, it does not experience a resultant force, or the resultant force is 0 on that. It means like one of the charges is attracting, another one is repelling. So they cancel out each other, their forces are balanced. So what charge I should place? If I check, I will check with all the options. I know the right answer, but to explain the idea, I will check with all the options. See, X and Y have a equal, X and like the distance XY is equals to distance YZ. So let's say if A was the right answer, means this is Q by 4. Let's say. So what will because the force between these two and the force between these two, they're cancelling out effect of each other. So here, what happened to the distance? If this distance I called R, so what is this distance? This will be R by 2. If I want the same force between the charges, if this distance I will say R dimension, this is equal, so this will be R by 2 or half of it. And what is the relation between the force? We have the formula that F is equals to K Q1 Q2 over R square. So what is the relation here between the force and the distance? It is inverse square according to Coulomb's law. So if the distance, if between X and Z, when I say X and Z, the force was F. Between Y and Z, what happened to the force? If a distance become half, if a distance is divided by 2, what happened to the force? The force will be multiplied by 4 because it is an inverse square. So when the distance become half, the force will become 4 times. If a distance become divided by 3, force will become 9 times. So it means the force become 4 times. So what happened to the charge? As we want to, we want to balance the charge, for that means if this force is 4 times, so what will happen to balance that, how much the charge should be, because they should have the same force. So if this distance is double or a twice is there, it means the force is like here. You have the formula. If I call, you can say also this distance is R. You can also say this distance is R. So this distance is 2R. And the force between a Y and the Z, you call that as a F. So what happened to the force between the X and the Z? The force between X and Z, because the distance will become twice. If a distance become twice, what happened to the force? The force will decrease by 4 because it is an inverse square relation. So if the force is decreased by 4, we want the same force. So how much should be the charge? The charge should be 4Q. So it will cancel out because we know F is equals to K Q1 Q2 over R square. So because of change in the distance, the force is decreased by 4. So how much the charge should be? The charge will be multiplied by 4 so that it will balance the decrease in the force. That's why D will be the right answer. Is it clear?